This tutorial is part of a YouTube playlist. You can access this and many more of the tutorials in this course. If you do like this YouTube playlist and you want to access the whole course, you can do on Udemy. The link to the YouTube playlist and YouTube course is in the video description. Right, so next up, the product line table. As we previewed in the previous tutorial, the product line table does have a relationship between the product as well as additional relationships, which we will include later once we have created the additional tables. So there is an obvious relationship, if you like, between the product line and the product table. We can't really insert the product line unless we actually have a product to associate it with. So the product, we start to build the t-shirt or the shoe or whatever it is. And then we go ahead and think about, well, how many product lines are we going to need? So we're going to need the red version of that shoe, the green version, the different sizes of those different shoes. So those product lines are associated to the product. So here we're going to need to create a foreign key between the product line and the product table. So moving back into our models file, let's go ahead and underneath the product table here, let's go ahead now and define our product line. So same again, product line, this time class. We're going to extend, like we have been previously, db.model, and then we give it a table name of product underscore line. Okay, so a similar set of fields. So we have an ID already. You can type it out or you can just go ahead and copy that. It's completely up to you. So that's our primary key for this table. Again, we're just going to create a new field called ID. So we're going to need some sort of price. So the price, here we're using a decimal field. So it's going to be a decimal field. We're going to specify 5 and 2. So here we're specifying the fact that the maximum number is going to be 5. So 5 numbers is the maximum for this column. So that will give us a maximum of, the maximum number that we can type in is probably going to be 99999. So that's the biggest number that we can type into this field. Now, the next number here is the decimal places. So 999.99. Sorry, so that will be the decimal places. So we're referring to how many decimal places we can include. So that will restrict and define the number system or define the restrictions for the numbers that we can include in this field. So we're going to need to bring in decimal. Okay, so we're bringing that in at the top here. Okie dokie. Okay, so just to formalize that again. So we have two numbers here. The first number is just defined as the precision. So this specifies the total number of digits in the number, including both the integer part and the fractional part. So the scale as this is described. And we have the second part, which is a scale. So this specifies the number of digits to the right of the decimal point. Okay, right. So the next field is, quickly take a look at the design, is the SKU. So this is going to be a UUID. So here what we're going to do is something slightly different. So whereas before we created the UUID in the database, here we can also specify creating a UUID before it hits the database. So as UUID equals true, let's go ahead and set the default to UUID.UUID4. Okay, so we're going to need to bring in the UUID resource for this. Just move to the top and then import that. So import a UUID, press save, it gets organized at the top. Okay, so that's just another way of creating a UUID. Right, so let's go ahead and create the stock. Stock quantity equals column. We're going to need to test all this stuff out. I'm actually not following what I consider as a good practice when building tables. So normally, I always recommend, particularly in an educational environment, is students create tables one by one. And as they create them, they test it as they go along and maybe make some queries, etc., as they go along. Too often or not, again, in an educational setting, you provide an assignment to build quite a large database. And then students end up trying to recreate the whole database at the same time and then follow on with that, creating queries, etc. And of course, if the database structure isn't correct in the first place and it's quite complex, you'll just never get to the point where you can then query correctly. And because maybe your knowledge isn't at that point where you're comfortable with understanding queries in general, it just makes a whole mess. So it's always better, 100%, do one thing at a time, one table at a time, build the table, make sure it works, make sure you can set it up, and make sure you can correctly query it at that point. And then you can build the next table and then build a relationship. Because what you want to also be able to do is replicate everything really quickly, or maybe roll back to a previous state. And so by doing things incrementally and potentially then utilizing some sort of way of, or using a version control system, you can easily like record different points of your development. So that's always recommended. So here we're just going for the jugular, assuming that everything is okay. But there's bound to be problems in the code, and we would deal with that as and when we get to the query stage. So we'll just continue creating these. So this is fairly self-explanatory probably at this point. Order, wait is active. So just keep bringing in the resources that you need. Okay, wait. And then created at, which is going to be very similar. So I'm just going to, we probably won't use updated at here, but you can do if you like. But I don't think I've specified created at in the design. I won't include that in. So that's created at. And then in addition to that, we're going to need to create our foreign key. So this is going to be product ID equals. This is going to be a new column. Going to be a integer. And then it's going to be a foreign key. So just specify product, the name of the table, and then the ID, the primary key field. Right, so there's our foreign key. So with this, like in the previous sections with the string representation function, let's go ahead and add one. So this time we're using the ID. So I'm just going to return the ID. There isn't a name here. What we can do is we can traverse. So what we can do is we can use the foreign key and say self dot, just as an example, this is just an example, we can say grab the foreign key and then inside of that, then go and get the name. So we can go from one table to the next and actually then get the name of the product it's related to. But I don't think that's really relevant at this point. If we're going to return something from the product line, we want something that's going to be associated to that particular product line. And at this point, probably the best case scenario is either the SKU, a stock keeping unit. So that's we're just making up this general idea that every stock item might have a unique ID associated to that company that's used for stock keeping, etc. But we're just going to return the ID in this case. Or should I say, we're going to show any objects that are returned. We're going to present it utilizing the ID of that particular object that we've returned from the database. So we have a similar example scenario again, where we have the product line table and we have the product table. So there is a relationship between them. So we're using the ID of a product. So if we have product number 1 and the name of that product is whatever it might be, some sort of shoe. So in the product line table, we're using the foreign key to build that relationship. So in the product line, we have a new record. We insert a new record, ID 1, and then eventually we get to the product ID foreign key. And this product might be the red version of that shoe. So I just put red there. It's not the attribute, but this might be the red version of that shoe. So in the product ID foreign key, we're going to associate that with product ID 1. So that's how we're going to then build a relationship between this data here and this product data. So when we query, for example, the product table, we build a query and we say, okay, get the product ID 1 and also show me all the product lines associated to that. So what we do is we can grab product ID 1. We know it's ID 1. And then what we do is that we can then look at the product line table and look for anywhere where the product line foreign key equals 1. And that way we can then return the product and the product line data in the same query. So that's the product line table built. At this point, you might start to feel comfortable actually building the product image table yourself. You can see there isn't really any additional fields that we haven't already introduced here. There is a foreign key like we had previously created. So let's next now create the product image table.